This conference will now be recorded.
All right. So anyone has got any idea what DevOps is? Simply put, DevOps is nothing but a methodology. Okay. It's a process kind of thing. Okay. Why do we need DevOps? So this is for quickening the process, deployment process using a set of tools. Okay. What do you mean by methodology? You can assume that to be a process to quicken the deployment process. అంటే మనం ఏం చేస్తాము అంటే we develop products, right? And we deploy these products, releasing it to the customer. Say, for example, it might be a mobile phone. Okay, so in order to release a phone, there are lots of things that will be happening in the background. First of all, we need to analyze. So what happens actually is nothing but your SDLC. What is this? Software development life cycle. Okay. What are the different phases of a software development life cycle? Analysis is the first phase. Analysis అంటే ఏం చేస్తారు మీరు? ఓకే, నేను ఒక మొబైల్ ఫోన్ రిలీజ్ చేద్దాం అనుకుంటున్నాను. దాంట్లో ఏ ఫీచర్స్ ఉన్నాయి? ఐ హోప్ ఎవ్రీవన్ ఈస్ కంఫర్టబుల్ విత్ తెలుగు. ఎనీవన్ హూ కెనాట్ అండర్స్టాండ్ తెలుగు or ignore. I'll just stick to English, right? Analysis. What do we do in the analysis phase? We analyze about the product. What are the functionality or features that I want to have as part of this product? What should be the price range? If this, say, assuming that I want to put the price as around 25,000. So if I keep the price of my mobile phone as 25,000, will people be purchasing it? Is it too high or is it too low for my features that I'm offering? Okay, who are the competitors that I have in the market already? Say, for example, I have Apple, Samsung, Vivo, Sony, blah blah blah, right? So a lot of companies are there. There might be future companies, say, assuming that I will be able to release this in the next 6 months. In the next 6 months, few other competitors might enter the market. Okay, what are they? What are the possible products they are going to launch? So if I launch at that particular time, will anyone purchase my mobile? Existing customers of other competitors, will they buy my phone? These are the things that I need to decide on. Assuming that I want to go ahead and build this project, the mobile phone, the next phase would be your design. Okay, what is the mobile phone going to appear like? Okay, what is the configuration that I want to have? What are the features that I want to have? So based on this, you will be designing. Okay, so after the design phase is complete, we move on to the development phase. It might be like assembling for assembling the phone. You need to create the outer shell. Okay, include a motherboard, include a processor, RAM, etc. and etc. Right? All these things you might not be manufacturing. At least you will be ordering these things. Okay, then you need to build an assembling unit, and finally you'll have to deploy. Once the prototype is ready, prototype meaning the first piece, for demonstration purposes will have a single piece, right? So once that is done, you will probably be testing it. Okay, multiple phases in software development. You will probably be having unit test cases written by developers, sandbox testing performed by QA people. Then you will have system acceptance test or user acceptance test, that is definitely from the client if you have a client. Okay, these things will be there, right? So testing, once the testing is completed and if you are happy with that, you deploy the product. Okay, so you release the product. Once the product is released, the next thing that we will be doing is supporting. Say, for example, you will have to provide some sort of a warranty. Okay, and customer support for at least 1 year. All right, depending on what you want to do, you'll probably be doing these things. So you need to have a customer support team. Okay, they need to know what the product is, what are the common issues that might happen, and how to fix them. If there is some hardware related issue, that has to be taken to your factory and has to be worked upon. Okay, this is typically what happens in a software development life cycle. Now, the traditional approach for SDLC model used to be waterfall model. Waterfall model meaning after the completion of one step, you'll proceed to the next phase. So once analysis is done, then only you'll be able to design, then you'll be able to develop, test, deploy, and support. Assuming I have an issue during the test phase, something is not working. Okay, what do you need to do? That needs to go back to the development phase and then test. If that requires some design change, then obviously that has to be happening. So again, the process will be followed using the waterfall approach. Unfortunately, what happens here is, say for example, initially I thought 6 months. Okay, now this, because of this setback, I need additional 2 months of time, so 8 months. Further competitors are going to enter your market. Okay, so that becomes very tough for you. And moreover, the features that you are planning, someone might already release them. If that is the case, what happens? Say for example, none of the phones right now, I think except for Sony mobiles, none of the phones are shatterproof, meaning if they fall down, your phone will break, your display will break, but not Sony phones. So I'm thinking of some sort of a similar thing, right? So in this case, what happens is, if your competitor release that feature before you can release the product, obviously some percentage of the market share is going to go away. In order to avoid these kind of things, we should release the product very quickly. How do you do that? That is using DevOps. DevOps is a process which helps you release the product very quickly, and that is achieved using some tools. Now, I said this is going to be a waterfall model previously. The latest model that we use is agile methodology, where you will have a shorter release period, meaning you will be releasing the product in a time frame of 2 to 3 weeks. It's not like you will be releasing the entire phone first, but you will be releasing the phone with basic functionality and add additional functionality later on, like releasing a software patch, releasing additional applications, right? Any bugs, obviously bugs will be there. So that will have to be fixed very quickly. You can't say, okay, I will release only every once every 6 months. In the meantime, these bugs have to be fixed. You can't wait forever. So you'll have to release that very quickly. So using agile methodology, you will be able to release the products in a very short duration of time, 2 or 3 weeks. I don't think in 2 or 3 weeks there will be a lot of people who can release mobile phones. Initial version will definitely take at least a few months, and thereupon you will be releasing new features every couple of weeks. So if you release new features, it will keep your customers interested. Otherwise, what will happen is they will migrate their mobile phones to other companies. You will be losing the market share. So in order to avoid that, you'll have to use the DevOps tools. Now, what are the tools that are there? By the way, not every tool that I mentioned here are part of DevOps tools. We used to use some tools like especially the VCS tool for, or for this matter, this can be called as source code management. Let me stick to one thing. Version controlling software. Okay, so version controlling software is not a DevOps tool. We have been using this tool since a very long time, more than 20 years. right? DevOps is relatively new, the process itself is relatively new, but we used this version controlling software since a very long time. What are the tools that are available? First and foremost would be Git, then you have CVS, SVN, lots of tools. Okay, why do we need this tool in the first place? Okay, so if multiple people are working on a project, obviously they will be working on the same files, especially when it is something related to utility files. Say, for example, I'm working on one of the app for my mobile phone. Okay, that app is nothing but a calculator. So as part of calculator, I have to provide some functionality. Say initially I'll have only four functions: add, subtract, multiply, and divide. Okay, so later on I'll need to add, say, something like log functions, okay, sine and cos functions, exponentials, power, etc., and etc. So this will go into a utility program. One developer will be working on power function, another developer might be working on exponential functions. Okay, so in that case, both the developers are going to work on the same file. So there will be a conflict as to who can save the file first, who has to wait for the other person, and things like that. Otherwise, what will happen? One developer will overwrite the code of the other developer, which is not an ideal situation. In order to avoid that, we will be using something called a version controlling software. Its responsibilities are only two. One is for logging and the other one is versioning. Why do we need these two? If there is some sort of a crash for this VCS server, we should be able to identify what caused the crash. In order to do that, we will go through the logs and identify the issue. The second advantage of using a VCS is we will be able to version. Say, for example, everyone is going to apply for jobs, right? So you will prepare your resume. So there will be multiple modifications. So current version is there with me, but I just wanted to have something like a tabular structure. Okay, for the skill set, I prepare my resume, update my resume, and save this. Once I save this, the previous changes will be overwritten. I'll have only one file. Now, tomorrow, someone said, okay, if you use the table, it looks like a childish kind of thing. It doesn't look professional. So what I do, I'll remove the table, at least hide the borders. The structure will be there, but no one will be able to see the border. It looks very neat in a proper format, right? Route. Then someone else suggested, okay, you need to highlight this, so better to put border and that to a bold one. So what I do, I want to go back. I don't want to redo my work. Rather, I want to go back. But do I have that functionality? No, because the moment I overwritten the code, that file is gone. Only the latest file will be there. So if I use something like a version controlling software, I will have the ability to have multiple versions of the file. Multiple files is different, multiple versions of the file is different. Multiple files meaning, say, for example, with yesterday's date, I will say something like resume with yesterday's date. That would be the file name. Today's file name would be resume with today's date. But unfortunately, what happens is you will end up having multiple versions, multiple copies of the file. But the problem here is I don't know in which file I have to check for the tabular format which I have done previously. For that, I need to maintain a record of a text file mentioning whatever changes that I have made. That is where your VCS will help. When you go through the logs, you will be able to tag it with a message. Okay, added tabular structure, removed tabular structure, kind of thing. So for this specific reason, we will be using something called a version controlling software. The developers will be saving their code in the version controlling software. Now, once I have the code, the next thing that I need to do is I will need to build the application, right? So for building, we'll have multiple tools again. Most commonly used are Ant, but that is an obsolete tool right now. The latest ones would be Maven or Gradle. Lots of other tools are also there, but I'm just mentioning the tools which are used mostly, like 80 to 90% of the time. These are the tools that would be used in the market. All right. So what these tools do, they will be building the application. What do you mean by building? You will compile your source code, okay, add any dependencies like additional libraries. Say I have given an example of calculator which uses a library called mathematic functions. So that would also have to be compiled as a library, and that would be added. Instead of sharing or deploying all these things, all these files, a project will have multiple files, hundreds, probably thousands, depending on the size of the application, hundreds of files. Instead of doing that, sharing this or copying this to the server, what you need to do, you need to create an artifact. Assume artifact is like simply compressing your files and archiving. So what do? You use something like a zip file. Okay, you save it as a zip file and share it as a zip file. So now I'm only sharing one file. Either it would be completely copied or not copied at all. If there is some issue, we'll get to know immediately. So if there are 100 files, how would you know whether the file is copied or not? You will only know when the application is actually deployed. In order to avoid all those things, what we do is we will be using build tools, Ant or Maven or Gradle, and you will be having an artifact. Okay, so that can be a zip file, that can be a jar file, that can be a var file, depending on the type of application you will be using it. If it's an Android application, that might be something like APK kind of thing, right? Once you build this application, you have to deploy this application. Now, where do you deploy this application? That would be inside of your web server or application server, depending on what type of application it is. Most commonly used would be Tomcat. You have WebLogic. You also have Glassfish. Lots of other servers will be there. The whole point of using a web server or an application server is to run my application. After the build is successfully completed, what happens is I will have a single artifact. That is what is called as a zip file or jar file or var file. I copy that to the server, start the server, my application is now running. Okay, now once I do that, I have application up and running. But there is a problem here. What is that problem? Hmm. Multiple people will be working. Multiple people will be working. So there will be issues. Like I told you before, when you use version controlling software, if some multiple developers work on the same file, that will create an issue. So what you need to do? You need to continuously integrate. Why? Otherwise there will be multiple versions of the project. Okay, at the end of the day, if you want to integrate once, what will happen? There might be bugs. Identifying the bugs will be an issue. If you go with continuous integration, the moment a developer saves their source code, it will automatically be building. Continuous integration is nothing but automatically building once the source code is saved. If there are some issues, it will immediately notify you, okay, about some errors. The developer who is responsible for the latest change has to fix that. All other developers will have to wait. Once that is fixed, the other developers can check in. Check in is fine, continuous integration is fine, but there is another problem: continuous deployment. If I don't deploy that, there will be some runtime errors. Say, for example, if an application, it's a simple mail application, okay. customers will be logging in. So there will be an application which takes username and password. Once I hit the submit button or login button, it will go and check the username and password. Where are these stored? That would typically be inside a database. So the application needs to establish a database connection. So if there is some issue with establishing database connection, the application should not start. Okay, so when will I know? Only when the application is running. So continuous deployment meaning it will run the application as well, where obviously inside of a Tomcat. Now none of these tools, we have Jenkins, we have Hudson, we have Bamboo, and lots of other tools. None of these tools are DevOps tools. We have been using these tools since a very long time, but none of these tools are DevOps tools. Now, what are the DevOps tools? Okay. First and foremost is I'm saying that I need to deploy my application inside of a server. Where is this server? Okay. That might be a physical machine. That might be a virtual machine. That might be a cloud instance. Okay. Physical machines, no one is probably using the physical machines because of the obvious disadvantages. We will be discussing that in cloud. Virtual machine is used, but most likely we'll be using the cloud instance. Okay. Now, someone has to create this. So I need to log into the cloud console like AWS console, management console, or Azure portal or GCP console. Then I have to create a server. Once I create the server, I need to install the runtime. Say, for example, if it's a Java based application, I need to install Java, configure the machine, copy the Java project jar file or var file, and then install Tomcat server, for example. Copy that var file to Tomcat location and then start the server. Who has to do that? I will have to do this manually, but manual process is tedious. If it is repetitive, we will definitely go for automation. And when we say automation, we will be using scripts, right? So in order to do all these tasks automatically, and by the way, you will not have just a single server. What happens if that server crashes? Your application will also crash. So for that reason, we will probably be having multiple instances of the server. Load will be balanced, and probably you will be having that inside of a cluster. Cluster meaning you will be managing the cluster. If one of the server crashes, the cluster is responsible for automatically creating your server based on the configuration that I provide. So all this automation involves DevOps tools. Okay. So what do? We use a few tools for software, or let me put it this way. Okay. Now IAC tools. IAC is nothing but infrastructure as code. So what I am doing, I'm writing some code which is responsible for creating an instance in the cloud. Okay. So that code, we have lots of tools. I can write that in Terraform. I can write in Ansible. I can write if in Cloud Formation. But Cloud Formation is specific to AWS cloud. But Terraform and or Ansible will work with any cloud. It might be Azure. It might be AWS. It might be GCP. It might be IBM cloud. It might be Oracle cloud. Okay, it will work with everything. Once I create the server, the next thing is I need to configure, like I need to install Java, I need to install Tomcat, and I need to copy the files. So this is what is called as software configuration. So for that we will be using something called SCM tools. What is that? Software configuration management tools. Most commonly used, most powerful, Ansible. Apart from that, we also have Chef, Puppet, Salt, lots of tools. Okay. Now, I will be able to do the configuration. Fine. This is good. But the problem is creation of servers, updations, patches that depends on the operating system and the features that I want to install. So for running a simple application, why will I need something like an FTP service or DNS service or DHCP service? I just need a server with basic OS, right? In that case, what I want to do is instead of going with a full-fledged cloud instance, or VM, I can go with a container. It is extremely fast. Say, for example, I have a feature phone, the button phone. I have a smartphone. Which one is faster? Remember, the primary use of a phone is to make a call. Okay. Which one is faster, smartphone or a feature phone? Yeah, I know everyone says it's a smartphone, but you're wrong. A feature phone is extremely fast. How much time does it take for you to switch on a phone, a feature phone, button phone? 10 seconds, 15 seconds at most? Okay. How much time do we need for starting a smartphone? Probably 2 or 3 minutes. It might be longer depending on how many applications that you have installed on that one. In order to make a call, do I need all these applications? No. So what can I do? If my usage is for making calls, I'll probably be using feature phone. Likewise, if I don't want all these bells and whistles, advanced features, what I can do is I can go with container. Okay. What is a container? It is simply put, it's like you can say that is a minimalized virtual machine. There will only be features which you need. Most commonly used container management tool would be your Docker. You also have Rocket, etc., etc., but most commonly used would be your Docker. Now, I'm creating a container. Fine. What if that container goes down? Again, my application will go down, right? So in order to avoid these kind of situations, we will need something called a container orchestration, right? For doing that, what we need is we'll need a tool called Kubernetes. We also have MISOS. Lots of tools are there. It's not like we only have this, but most commonly used tool would be your Kubernetes. Okay. Now, apart from this, we'll also need to have some knowledge on monitoring tools. Okay. Most commonly used Nagios, because Nagios is capable of monitoring your application, monitoring your network, monitoring your server hardware as well. Say you also have something called Neuralink. Neuralink is used only for monitoring of your applications. Likewise, Grafana, right? Zabbix, lots of other tools. If I go with AWS Cloud, I have something called CloudWatch. Lots of tools depending on usage, depending on your company's requirement, you will be forced to use these tools. Along with this, there are a couple of other things. Okay, say for example, we are building an application, right? There are things like identifying some known issues kind of thing. Okay, say your hackers might be able to hack your code depending on the quality of your code. So in order to do that, what you do is you check your code, static code analysis. Okay, for doing this, what you will do is you will be using something called SonarQube, or you can use Checkstyle, you can use PMD. Lots of tools are there. What these tools will be doing is they will check your code for any known bugs. Okay, say if you are trying to log in, a hacker might say something like after password they'll put a semicolon which indicates the end of the command, and they might be doing something like select star from users kind of thing, so which will hold all the users data. They will get the entire data back. So in we will be able to do check for all these kind of things. Also there is something called as artifact repository. Okay, lots of tools again. We have Nexus, okay, we have JFrog, etc and etc. What is things do? They will be storing the built artifacts. The moment you build, the output of this step will be your artifact. I can store it in version controlling software, nothing is stopping me, but you will not be able to compare. First thing is it's bad because you're only supposed to save the source code, okay, not the libraries. You will be able to compare the source code, but even if you save the libraries, you will not be able to compare these two libraries. So in order to avoid that, we have something called as a artifact repository, which will let you store the libraries with versioning. Okay, so that is the reason why we will be using this. Okay, along with this you need to have some sort of a scripting language. Okay, so why scripting? It might be as simple as shell, but no one is using shell scripting right now. Probably some companies are using Python, but most likely you will be using Ansible because it is extremely powerful. And moreover, you don't need to code in case of Ansible. You'll be using pre existing code. Just fill in the templates, fill in the values, and you are done and dusted. You don't need to code too much in case of Ansible, or for that matter any software configuration management tool. You will be able to do that. So this is what we are going to discuss as part of DevOps. Okay, now previously I said that we will be using cloud instance. Now what is a cloud? Okay, simply put, cloud is nothing but accessing services, okay, obviously via internet, anywhere in the world. Okay, now what do you mean by that? What is a service? There are three different types of services. First one is infrastructure as a code, as a service, sorry. Then you have platform as a service, and then you have software as a service. Right. Now what do you mean by infrastructure as a service? What is infrastructure? First of all, nothing but your hardware. When you purchase a desktop or laptop, what do you have in that? You'll have the hardware: processor, motherboard, RAM, hard disk, right? Speakers, mic, etc and etc. That is nothing but your hardware. What is the first thing that you do once you have the hardware? You install operating system. It might be Windows or Linux. Then you'll also be installing the software. Say for example applications like Microsoft Word or Java or .NET, etc and etc. The same thing you'll be getting as part of your infrastructure as a service. I get the hardware in the cloud: Azure, AWS, GCP, IBM Cloud, Oracle Cloud, doesn't matter. Anywhere I get this service. Once I get this service, I will be doing the OS installation and install the applications as per my requirement. If I go with platform as a service, now what is a platform? In simple terms, it is nothing but hardware plus operating system. Actually it's environment. Say for example, if I am trying to deploy a Java based application, It includes your hardware plus operating system plus the Java environment configured appropriately. So what do I need to do? I just need to deploy my application. Assuming I'm deploying a mail application. Here I will get only hardware. So I need to install operating system and then install the mail application. But what if I get hardware and operating system? I just need to install the mail application. Now, in case of software as a service, you already have everything that is required. Okay. Example would be, do I need to install anything here? Not required. Why? Example, you're accessing Gmail or Yahoo Mail or any other mail for that matter. In order to use that, are you installing any software on your this thing? Not required, because your operating system will have a default browser. If you want, you can install an additional browser, but that is optional. You don't have to do that. So you're using mail, whether you know it or not, you're already using cloud computing. Okay, cloud computing is nothing but accessing a service over the internet. Okay, three types of services: IaaS, PaaS, and SaaS. Now, what are the advantages of using cloud computing? Two major advantages. What is that? No upfront payment. If I want a physical server, I have to purchase that. So I need to spend some money. If it's costing 1 lakh or 2 lakhs, sometimes depending on the configuration, that might be hundreds of crores of rupees as well. Okay. Simple example, in 2004, we had tsunami. So the government of India has spent around 500 crores on the project. What does it do? It captures high resolution images and analyze those images and warn the people beforehand about any tsunamis that might occur. For processing this, we need huge capacity, computing capacity. The cost of the servers itself was around 400 crores. It was a very powerful machine. I don't want to take names. The cost of one server itself was like 400 crores. Just imagine, what is the size of a normal picture? Probably that might be in KBs. But if you go with high definition, high resolution pictures, it might be running into few MBs, 25, 30 MB. We are speaking about huge data. So that might be GBs of pictures alone. So in order to process that, we need image processing capabilities. So we needed to spend more on the configuration. So the same thing, if I go with cloud, I don't need to make any upfront payment. Depending on the usage, I will pay. Say, for example, for some reason, the mobile connectivity is not working on my phone. I can't check data, check my mails. So what do? I go walk into an internet center. Of course, these are not available as they used to be in the previous days. I walk into an internet center. Do I need to pay anything upfront? No. What I do, I'll probably be using for 1 hour, pay like 10 or 20 rupees and walk out. But do I purchase a machine, take internet connection, and then browse the mails? No, right? That involves upfront payment and it will take time. Here, it's already available as a service, so I use it, pay as per my usage. That is the first advantage. And the second advantage would be something like auto scaling. Now, what do you mean by auto scaling? I'm pretty sure everyone might have booked tickets either in Book My Show or IRCTC website or any other site like Redbus or something like that. So, obviously, what happens? Today is a holiday for everyone, right? So, my holiday calendar is released. So, what I'll do, I will try to book tickets. It's not like only I am going to book tickets for the long weekend, Saturday, Sunday, and Monday. Everyone has the same plans, right? So, what they will do, they'll try to book the tickets. All the people log in at the same time, resource usage will be high, server cannot handle the resource usage. So what happens? The server might crash. If I know the situation beforehand, what I can do is I can have multiple servers, okay, and then I will be able to manage the load. But what happens after the tickets are sold out? My resource usage will be less. What happens to the additional servers? Mind you, these servers are extremely expensive. So what will happen? I'm wasting money. But at least my application is working fine. So that is a plus point. Assuming there is something like unforeseen event. Okay. So previously, a couple of days ago, we had Ganesh Nimajjanam, right? So unfortunately, on that day, there was a cyclone, huge rains. So will the immersion takes place on that day? Probably not. That might be postponed. So what will happen? Assuming that fell instead of on a Saturday, that fell on Sunday, Monday. Generally, you will do the immersion only on odd days, like first day, third day, fifth day, seventh day, and finally ninth day. If it falls on a Tuesday or Friday, that will be pushed to 11th day also. Okay, so the postponement happened and it fell on a Monday. Now that is an extra thing. So what will I do? I try to book tickets, go to my hometown, right? Everyone will have the same plan. So what will they do? This is an unforeseen situation. So the servers, the application owner might not know about this one. They cannot estimate this scenario will happen, so they don't expect this situation to happen. So what they do, they can't do anything. Suddenly the application crashes. Can we do anything? Only thing is you have some additional servers, but not everyone is capable of doing that. Only big companies can do that, right? In case of cloud, what I can do is I will specify a condition. Okay, if my resource usage is greater than say something like 80%, create a new server, okay, and then deploy my application. Okay, if that condition is met, take this action. That is what I'm going to specify. That is what is going to happen automatically, right? So there is no way the application is going to crash, because it will keep on increasing the servers, and once the load is down, it will decrease the servers as well. So you're not going to incur some additional costs also. Okay, so these are the two major advantages of using cloud. Now, who are all the vendors that we have in the market? Lots of vendors: Amazon, Microsoft, Google, IBM, Oracle. Lots of vendors are there. These are not small companies, mind you. Amazon's product is nothing but AWS, Amazon Web Services. Microsoft product, Azure. Google product, GCP. IBM product, IBM Cloud. Previously, it used to be called as Bluemix. They have purchased some other cloud computing companies. Similarly, Amazon has tie up with virtualization leader VMware, and Oracle has got OCI, Oracle Cloud Infrastructure. Lots of vendors. Which course should you learn? That depends. Huge market share is with Amazon. Almost roughly around 50% of the market share is with Amazon. Then you have Microsoft Azure Cloud. Okay. Now, the moment you deploy all these things, okay, this will most likely be on a Linux machine. Reason is, lot of DevOps tools can only be installed on Linux but not on Windows. VCS, this can be installed on Windows because it's not a DevOps tool. Build tools can be installed on Windows. Web application servers can be installed. CI/CD can be installed. But what about this tool? Yes, this is an exception. IAC tool is an exception that can also be installed on Windows. But what about SCM? No, it cannot be installed on Windows. Container management cannot be installed on Windows. Kubernetes or Mesos cannot be installed on Windows. Monitoring tools, not exactly a DevOps tool, that can be installed on anything. This one again can be installed anything, but will also be used only on Linux. So you need to use a vendor for providing this infrastructure. Once you have the infrastructure, you will be installing any platform of Linux, probably Red Hat or SUSE Linux, most commonly used flavors. Previously we used to use Solaris, okay, and AX as well. But again, AX on cloud is not that easy because it is hardware dependent and it can be installed only on IBM cloud. That's a dependency. Okay, so we are going to install on Linux machines. Now, for that, you need to have an understanding of Linux, at least the basics part. Okay, because you are going to do the installations using the Linux commands. For that, you need to create some users, create some permissions, and know some commands to do day-to-day actions. But it would also be beneficial if you have some sort of Linux admin knowledge, okay, because there will be some advanced concepts, so it makes sense for you to learn Linux administration as well. But as of such, Linux basics is required. So if you want to learn DevOps or any cloud, you need to have Linux basics. This will be approximately 1 week to 10 days. Once you are done with this, we will start AWS or DevOps depending on which one is available, which one you're enrolled in. So this will take around 45 days. Okay, there will be some any cloud, AWS or Azure or any cloud for that matter, GCP also. Okay, and then we also have DevOps. This will again take roughly around 45 days. This is the maximum time that I'm saying. It will be completed sometime between 30 to 45 days because there will be overlap to some extent. So that would be covered within 45 days. So if you enroll for all the three courses, that should be taking you around 75 days, 2.5 months. Okay, 2.5 to 3 months at most. Okay, so this is regarding what we are going to discuss as part of cloud. Again, when we say cloud, there are like 200 plus services in any cloud. Okay, so we will be discussing the most commonly used tools. Right, in case of AWS, we'll be using say something like EC2, IAM, S3, VPC, CloudWatch, okay, RDS, DynamoDB, Route 53, etc. and etc. Commonly used 6 to 7 services, depending on requirement. Say, for example, if you want to use AWS services, okay. So, in case of Git, the corresponding tool in AWS would be code commit. The similarly, you have on Azure, we have something called Azure DevOps. Inside that, you have something called Azure Repos. Okay. In case of Jenkins CI/CD tool, we have something called code build and for integration, and then code pipeline. Okay. In case of Azure, you have something called Azure pipelines. Okay. For Kubernetes, you'll have corresponding thing. For Docker, you'll have the corresponding service. Okay. For servers also, you'll have corresponding services. For databases, you'll have corresponding services, and code related tools like you'll be using something like IDEs. Okay. Say something like Eclipse, you'll have corresponding tools. Okay, so this is what we are going to discuss. Clear? That is regarding your